So diffusion models are probably, I think, the future of reasoning because they can edit their own thoughts and plans. So in this video, we will explore a new way that diffusion models can do that and improved ways, and write some code. The only reason I think big companies like OpenAI and DeepSeek are not writing diffusion models right now is because LLMs are there's just more effort put into it, but maybe diffusion models are actually better, and once we put more effort into diffusion models and reasoning, it will be better, I believe. Here, guys, I got the reasoning formula. So diffusion models can reason better as they can edit their thoughts. Generate data with good LLMs on solving, for example, machine learning coding challenges with comprehensive comments explaining step by step the thinking process and planning. So you use a small diffusion model to distill the large LLM's data. Diffusion model will learn to plan in comments and write code because it goes back and forth. And then use reinforcement learning with just correct answer for coding. Generate a bunch of coding challenges. Maybe it's easier to generate than to solve them. Maybe you can just start from the answer and then give the task. It's easier to generate, to come up with the problems. You don't even need to know how to solve them with code. And then just apply the reinforcement learning there, and then diffusion model will learn to plan. So we got this blog post from DreamOn. Basically, they explain how to make diffusion models generate variable length amount of tokens, not just when you say, okay, generate 20 tokens and then you generate 20 masks, as I explained earlier. Oh, I think I get their idea. So they have a mask token and they can turn that into expand token, which will then in the backward pass duplicate. So expand turns into 2 mask tokens. Or if in the forward pass they turn mask token into delete token, then in the backward pass it will just get removed. But take that with a grain of salt. I'm not sure if I understood it 100% correctly, but here is their training process, which I like. So they have a sentence: Diffusion LLMs for code in filling beyond fixed size canvas. Then they will process this sentence. When they are processing data, preparing the data, they're gonna randomly merge some of the tokens into this expand token, like these two into this expand token. And they will randomly add these delete tokens, I'm guessing, at the end. Or maybe even somewhere else, we'll see. Yes, so they are denoising expand and delete from mask directly, just as if they were regular tokens. So this is how they do it. They have this sentence, and they, in the beginning, and then they just swap everything with mask tokens, and they randomly merge a few mask tokens into expand token, and they randomly add these delete tokens anywhere in the sequence. Now they show here that 3 tokens are merged into expand token, but I'm guessing that in reality they will just first merge only 2 by 2, and then when they merge, I'm not sure. So maybe they merge these two, and then the new mask token and this mask token, they get merged into this expand token. So they have 2 ways of merging mask tokens into expand tokens, one with fixed merging probability, and the other depends on the number of mask tokens in the sequence. And the best way is to combine both of them. So they train on this data OpenCoder LLM OPC SFT supervised fine-tuning stage 2 on Hugging Face. It's just like tasks. So write a function that does this, and this is the function and the code. So here is the code to solve this. This is. This is the answer that it should write. So I just copied the entire blog, and I told Claude, code the simplest possible diffusion model that will train in Google Colab GPU quickly, like this. Also show how it works with slow inference. So this is the extent of prompt engineering nowadays that we need, because now I want to let Claude decide what kind of training and data it will create, because it knows better. So I just told it to generate the model. So we got the error. Also, I want a transformer architecture, not UNet architecture. So I will say also I want transformer architecture, not UNet. Okay, that's it. Now imagine how much faster this could fix the code. Right now it needs to recode everything. But if we had a diffusion model that's as good as this Claude, it would be way faster. It would be like an instant. So if we can match the power of diffusion models with autoregressive ones, they will be a lot faster. And now it's training very fast. Okay. That's crazy. Okay, let's see what we even have here. Training loss going from 0.6 all the way down. Generating images from diffusion transformer. But I did not tell it to generate, like in the variable text thing. Text stuff, not image stuff. Oh my god, this is original training data. And this is the generated. I don't think it's good. I don't think it's good. It's just pure noise. Now I used Claude Opus from LM Arena. You can use direct chat. And it looks like now it's generating these things, like 2 plus 3 equals 60. 5 plus 4. Okay, so it's not correct. I guess the training, we need more training. So I'll just tell it to give more training to the thing. Actually, I just pasted these results and it's gonna see the problem. And now it's gonna use a cleaner approach. Let's see what it does. Okay guys, we trained it, but still 0% accuracy. Why is it always generating 3 numbers? I'm not sure. I need to look into the code deeply now and understand it. But this may be the path forward for reasoning, because it can self-edit thoughts. So this was just a quick blog or introduction of, in my opinion, of diffusion models. I'm gonna make more videos. If I decide to go down this path, I will decide if I find this to be the most likely path forward for more smarter planning and reasoning models. So you can expect more videos and real tutorials. This was more like a vlog or live. So see you next time.